In this video for section 4.2, we're going to start by looking at the graphs of logarithmic functions. To graph a logarithmic function, we use the fact that it is the inverse of an exponential function. So that means that we can take the exponential function and switch the x and y coordinates to get the graph of the logarithmic function. So we're going to do example 6 here from the textbook. It says to graph f of x equals 2 to the x and g of x equals log base 2 of x in the same rectangular coordinate system. So I'm going to start with f of x equals 2 to the x. And remember, we can replace f of x with y. So this is y equals 2 to the x. And we did this graph back in section 4.1, so it should be review. We're going to plug in -2, -1, 0, 1, and 2 for x. Plugging in -2 gives us 1/4. Plugging in -1 gives us 1/2. Plugging in 0 gives us 1. Plugging in 1 gives us 2. And plugging in 2 gives us 4. And if we plot these points, the graph is going to look like this. So now we're going to do the graph of g of x. G of x equals log base 2 of x. So remember, we can write this as y equals log base 2 of x. Now if I rewrite this in exponential form, I get 2 to the y equals x. And this shows why the two functions are inverses, because in the equations, I'm just switching the places of x and y. So as long as you have the same base, then you can just switch the x and y coordinates of the exponential function to get the points on the logarithmic function. So that's what I'm going to do. Now when I plot these points, the graph is going to look like this. So remember that when we have functions that are inverses, they are reflections over the line y equals x. And if I draw in the line y equals x here, I can easily see that the red and blue graphs are reflections over that dotted line. So next you should look at checkpoint problem number 6. Do this in your notes, check your answer, and then move on with the video. Next, we're going to talk about a special logarithm called the common logarithm. This is a logarithm with a base of 10. So if we see a log that does not have a base written, then it's assumed to be a base of 10. And we've seen that before in other situations where we have like an invisible 1. In this case with logs, it's an invisible 10. You should be able to see a log button on your calculator somewhere. That button is going to evaluate common logs. So if you type in log of 1,000 and then hit enter or equals, then the calculator will give you an answer of 3, because 10 to the third is 1,000 and it's doing log base 10. If you want to do a log with a different base, then you have to use a different process that we're going to talk about a little bit later on. But just remember that the log button doesn't do all logs, it only does logs with base of 10. On most calculators, that is. So we're going to look at example 8 from the textbook. It says the percentage of adult height attained by a boy who is x years old can be modeled by this function. X is the boy's age from ages 5 to 15, and f of x is the percent of his adult height. Approximately what percentage of his adult height has a boy attained at age 8? So x is age, so that means I'm going to be plugging 8 in for x. So f of 8 equals 29 plus 48.8 times log of 8 plus 1. And I know 8 plus 1 is 9, so I could just write log of 9. Now, if you're doing this on a calculator where you can type everything in all at once, then you should do that. You would want to put parentheses around this 8 plus 1, just like there is in the problem up here. Or you can just type 9. You can do that in your head pretty confidently. If you're not using a calculator where you can type it in all at once, you would do log of 9 first on your calculator, multiply the answer by 48.8, and then add 29. Make sure that you do the correct order of operations. And if you do that correctly, you should get an answer of 75.57. Now, in the homework for this section, it's going to ask you, I believe, to round to 2 digits after the decimal point. This is a percentage, percent of adult height. In the book, they round to the nearest whole number. I'm not sure why it's different. But just make sure, of course, that you're paying attention when you're doing the homework and quizzes and exams to how many digits after the decimal point they would like. So 75.57 or 76%. So next you should look at checkpoint problem number 8. Do this in your notes, check your answer, and then move on with the video. We have another special type of logarithm called natural logarithms, and these are logarithms with base e. So we talked about the number e before, and e is so widely used in applications that it has its own special logarithm, natural log or ln. So we write ln even though it's natural log instead of nl. You should find on your calculator an ln button, and with that button you can evaluate natural logs. So we have this example here, example 11. When the outside air temperature is anywhere from 72 to 96 degrees Fahrenheit, the temperature in an enclosed vehicle climbs by 43 degrees in the first hour. And we have this function that models the temperature increase, f of x, in degrees Fahrenheit after x minutes. Use the function to find the temperature increase to the nearest degree after 50 minutes. So 50 is going to be x. So I'm going to plug in 50. So we have 13.4 times ln of 50. Now, on most calculators, when you use log or ln, when you hit that button, it automatically opens a parenthesis for you. So if I'm plugging in 50 for x, it's really important that I close that parenthesis after I type 50. Otherwise, your calculator is going to do 50 minus 11.6 and then take the natural log of that, and that's not what we want here. The natural log is only applying to the x. If I wanted to do that, I would put parentheses around these. So just make sure you're closing that parenthesis after you type 50. And then you're subtracting 11.6. And if you do this, you should get 40.82. And it's telling me to round to the nearest degree here, so I would need to type in 41 degrees. So next you should look at checkpoint problem number 11. Do this in your notes, check your answer, and then move on to the homework.